Okay, so in this lesson we discuss Zenon network. What is Zenon network? A brief overview of consensus and the different types of consensus types, and then a brief overview of the distributed ledger, and then we'll talk about how Zenon network comes into this. A first and a quick overview of Zenon network is that it's one network that has two tokens, the ZNN token and the QSR token. The next thing is that it's a system that has two layers, or you can say two layers. One of the layer is called the storage layer that you can use to store transactional data, and the next layer has to do with consensus itself. So let's talk about a brief overview of consensus algorithms. So consensus algorithms, we already know that we have the likes of proof of work, proof of stake, and all that. So, but before we talk about that, how do we rate different consensus algorithms? We rate them based on performance, and then we rate them based on security. For performance is how many transactions can it process per second. We talk about throughput. If we add more nodes to the network, with the network scale or with the performance be degraded, we talk about scalability. Can the network continue to be functional in the midst of adversary or fault? We talk about fault tolerance. How long does it take to confirm a transaction? We talk about finality or latency. For security, it's not just enough that the network can perform very well. How secure is the network? Can the network withstand against zombie attacks when people are trying to spam the network? Can the network withstand against Byzantine attacks when people are sending different signals to different people? Can the network withstand against denial of service attack? Somebody wants to join the network as a node. Can we deny that person such a privilege? Can we say a transaction will be censored? Somebody is from location X. Can we censor that? We're not going to confirm the transaction. If any of this, if the system has a high pass mark on this, we can say the network is truly, and the consensus is truly fabulous. And there are different consensus on the market, and we have the likes of proof of work. So we have it in Bitcoin. It has its own problem. It's the one of the most secure network, but it takes too much energy. It requires high amount to start up. There is e-waste. There is high carbon footprint and other disadvantages. That talks about replacing computational power with stake. Talk about proof of stake, which Ethereum is actually transitioning to. And there is another variant of it, which is called the delegated proof of stake, which the likes of EOS uses. So in this system, you elect leaders. So it's like the normal world. Everybody cannot come and be giving their input on decisions. No, we have, like in the US and other places, you have senators, right? You elect the senators, and in your constituency, when you have issues, you go to the senator and you lay your complaints and you say, okay, this is what we think should be done. This is the kind of law that these are things, and then they go and they. So in the system, they have what called block producers or committees. For US, the delegates are 21. For list is 101, and other systems like Tetos, it is randomized. The next is using Byzantine fault tolerance system. They have been here for a while, but nowadays, rather than people just use the Byzantine fault tolerance system, they mix them with things like proof of work or proof of stake. So we have the likes of Tendermint and Zilliqa that have the hybrid Byzantine fault tolerance. And the next consensus algorithm is what we call the visual voting, of which I want to spend time on. So this is somebody in the network, this is another person in the network, this is another person, this is another person, this is another person, this is another person. So this person receives transaction. So when they receive transaction, in order to acknowledge that they received transaction, they will have to tell other people that they received transaction. So they gossip about the information they receive and also the transaction about the information they receive. So this person gossips to this person and say, I received this. This person says, oh, I received this information and I also receive a gossip about the information from this person. So he transfers it to this person, and then it goes on and on and on and on. So at the end of the day, this person would have heard, everybody in the network would have heard what every person in the network would have heard. So it's like gossip, so you've heard about everything. So it uses the visual voting. And in this system, it sees everything as messages and then that. And then there are other variants of consensus algorithms. That's why I talk about proof of X. I talk about things like proof of importance, talk about proof of capacity in the likes of burst chain. We'll have proof of authority, proof of retrievability, proof of elapsed time. There are, I think, over 100 consensus algorithm. So you might be asking what consensus does the Zenon network use? It uses the virtual voting system. So I already talked about the gossip about gossip system. We'll talk about how it works in a minute. And not only that, it brings in a hybrid of the proof of stake. So for the consensus part, you will need to stake some tokens, and then it also uses some form of proof of work, of which we'll explain what or we're explaining proof of work links later on. So let's talk about the blockchain, the DLT side of it. So many people have often confused blockchain to be distributed ledger technology. So it's like actually saying that let's say a state, California, is actually the US. No, California is just part of the US. So a blockchain is a subset of the distributed ledger technology. So first overview, distributed ledger technologies are basically technologies that help in storing data in a distributed fashion. We have blockchain, which is the most popular. It uses a linear kind of system, a linear data structure, and it has what we call blocks. So, and then these blocks are linked together using what we call tree. So there is hash and then there is tree, of which I will not discuss here. So it uses what we call the longest chain principle, where the people, the miners that is able to produce the largest block, the longest chain will be the one that will be accepted. And with blockchain, in this system, you can see that this is a transaction, this is a transaction, this is a transaction, and then this is the block itself. So once transaction gets added to a block, the transactions, there will be some form of work, they will be confirmed, and then they will be chained together to other blocks, and then the process continues from the genesis block. So this is block 0, which is genesis block, to infinity, if you say. So the next form of consensus, the next form of distributed ledger technology is the DAG. So the DAG uses what we call the block graphs or the tree. So the DAG is called the directed acyclic graph. So it's a graph that is not cyclical in itself. So as you can see, this is not a cycle. So it's non-cyclical. And a very good implementation of this distributed ledger technology is in IOTA. So in an IOTA, for your transaction to be confirmed, you have to confirm 2 previous transactions in the system. Now, one of the problems with designing this system is security, because this system is very, very fast, right? But how do you design security in the system? That is one other challenge. And the next system is the Holochain system. So the Holochain system takes concepts like distributed hash tables, Git for version control, and then BitTorrent's famous file sharing system to create something that is very, very unique. And I made a very good comparison between a Holochain and the blockchain. So you may look at a blockchain to be a single business entity that have to handle every single kind of request. For the Holochain, you can see it to be a co-working space. So when you are building a co-working space, for example, this is an office space. This is an office. This is an office. This is one office. This is another office. This is another person. Businesses, another. So this person may be dealing with clothes, and this person may be dealing with food. This person may be dealing with cars. So it's not like this where they sell everything and you just go, nobody asks you. In this space, when you come in and say, I want to buy clothes, there is somebody that wants to attend to you. So that is the approach that the Holochain system takes. And it's very, very scalable. It does not replicate data across everywhere. And then the last one we'll talk about is the block lattice. So the block lattice takes the account chain model. So what that means is that it says every single person in the network that has an account should also keep their own records. So it's not saying that we are delegating the burden or the responsibility of keeping records in the system to one person. No. If you as a user in the network keep your own chain, so you can always update your chain anytime and add it to the network. Now this accounts for concurrency and then independence, sorry, and also scalability. Now, let's come back to. You might be asking, what does Zenon network do? Now, for the Zenon network, you might be asking, what kind of system does Zenon network use? I want to say the Zenon network uses this and also this. So it uses a metal dark structure, a hybrid of it, and a block lattice. So a metal dark and a block lattice. So let's talk about some of the nodes in the network. So we're talking about nodes in the Zenon network. So we have the trusting nodes, the trustless nodes, and then the pillar nodes. The trusting nodes, they are lightweight, and they store transactional data or a proved version of them, and then they also monitor traffic for specific accounts. We'll discuss that in a bit. For the trustless nodes, they are moderate. It takes moderate resources to actually run them. They help create proof of work links, and then they act as observers in the network. For the pillar nodes, they are also referred as consensus nodes. They take high resources to actually run. They engage in consensus, and they help relay network traffic between other pillar nodes in the system. And that leads us to the proof of work links. So you might be asking, how TS works? Okay. Low battery. Ooh.